In this tutorial, you experiment with the Voxel Solver that makes skinning characters a much easier task than it ever was before. To use the Voxel Solver, you need to have 3ds Max 2016 Extension 1 or newer. To that end, you will use the file named zombie voxelskin.max, which features an old friend. It is the same zombie character that was used in the Rigging a Character tutorial series found on this channel. In fact, in that series, there are 13 movies dedicated to learning how to skin a character. The explanation to that purpose ran well over an hour, and although it is still useful today, the new algorithm will cut that time to a fraction. Select the body in the viewport and apply a skin modifier to it. Using the Add Bones tool, choose the selection set named Skin Body Bones, thus selecting the bones that affect the body. These are essentially most of the bones in the skeleton, except for a few nubs, and some additional bones to blend FK and IK. In essence, the workflow so far is not any different from what it was before. Case in point, scrub the animation and notice the same weak skin solution around the ankles, knees, and pelvis. The skin modifier uses a default solution to affect all vertices on the mesh, but it is seldom acceptable. By turning Edit Envelopes, you can see how various bones are affecting their surroundings. The default blending between bones leaves a lot to be desired, creating major problems around joints like thighs and shoulders. Enter voxel skinning. In the Weight Properties group, a voxel weight solver is displayed. Access its settings dialog by clicking the little box next to it. The fall-off value determines the smoothness of blending. A lower value gives a smoother solution, while a higher value is more rigid. Start with the default value of 0.2 and adjust it from there. The max influence value is the same as the bone effect limit value that you already know. Basically, it determines how many bones affect a given vertex. You can force a number, or you can leave this value at 0 and let the software decide for you. The max resolution value determines the accuracy of the solution. Higher numbers require more processing time. Start at 64 and work your way up. As you click Apply, you should see a significant change in the solution, both in joint deformations and in envelope colors. Try varying the values a bit to see the changes. Try a maximum influence of 3, 4, or 6 bones, and play with the fall-off value as well. If you went through the original character rigging tutorial, then you know how much time you have just saved. It's important to remember that this solver is not a magic button, even though it does a very good job with the solution. Although it looks like it worked beautifully here on ankles, knees, pelvis area, torso, shoulders, elbows, and wrists, it does seem to still have an issue where bones and meshes are too close together. In this case, the fingers are definitely a problem area to fix. Still, 95% of the work has already been done, so you can spend the last 5% fine-tuning the solution the old-fashioned way. This means you can dismiss the Voxel Solver dialog, enable vertex mode, and start editing vertices. Once you have selected a set of vertices, Then you can use the weight table to work out the blends between the various bones. Similar problems can occur in other areas as well. The head is a good example. Select the head and apply a skin modifier to it. Use Add Bones to add the selection set named Skin Head Bones. Scrub the animation towards the end. The default solution looks awful. Apply default Voxel Solver and check the results. Even though they are better, there is a bit of an elastic stretch applied to the geometry. In this case, the skull, nose, mouth, and chin areas should all be following the head bone. The neck area, however, should blend between the head and neck bones. You may want to isolate the head to see the effect better. And so, even though the Voxel Solver gives you a good head start, you still need to adjust the solution at a vertex level. The skull itself should be solely driven by the head bone, but the base of the skull should be blended a bit with the neck bone. Select vertex loops and adjust the blending in the weight dialog. Similarly, the base of the neck should be affected only by the clavicles, whereas the rings of vertices above the base should be gradually affected by the neck bone. Finally, the rest of the meshes, such as eyeballs, teeth, and tongue, are in this case rigid and need only be linked to the head bone. And just like that, you skin this zombie character in around 10 minutes, whereas it took well over an hour using the techniques showcased in the old rigging series found on this channel. Think about how much time you'll save working on your own projects.